So the next space curve is the helix, and here's the exercise. So we need to sketch the space curve whose position vector is given by the vector function cosine ti plus sine tj plus tk. If you consider just the I and j component, what does it look like? If k did not exist, let's, it's a circle. Cosine, if you have x correspond to cosine t, y correspond to sine t, then if you square them both, then you have cosine squared, or x squared plus y squared equal 1. And that's a circle. So if you do a cross section, for instance, you apply a certain value to t, and you have a cross section or a trace that is parallel to the xy plane, right? For instance, if you let if you let t goes to 0, if you let z goes to 0, it means that t goes to 0. So you have the point cosine t is cosine of 0 is 1. You have the point 1, 0, 0, right? And so on. So let's look at it on the next page. Actually, let's do it right there. First of all, the parametric equations are x equal cosine t, y equals sine t, and z equals t. Start with that. So now what I'll do, I'll hold a constant value of z. So suppose z equals some constant k. This is a different k value. Remember, we have k that is part of the ijk, the standard unit vector, and this is a k that is a constant, right? Then the horizontal trace that is parallel to the xy plane is given by the circle, sort of x squared plus y squared equal cosine t squared, cosine squared t plus sine squared t, and that's equals 1. Okay? In other words, we have a circle centered at 0, 0, and then that k value with radius equals 1. Okay? T equals 0 corresponds to the point if you remember that cosine of 0 is 1, so you have 1 0 0 sine of 0 is 1. T equals pi over 2 correspond to the point 0 1 and pi over 2. Remember t equals pi over 2. Okay, t equals pi correspond to cosine of pi is negative 1, and here we have 0 and pi, and so on. Notice that the x and y values will be points on the circle. Okay, and we can do it again. T equals 2 pi correspond to the point 1 0 2 pi. I didn't include 3 pi over 2. But you can imagine, well, you know what, let's do 3 pi over 2. So this will be 0, negative 1, and 3 pi over 2. And now we'll do t equals 2 pi, and we'll finish the circle. So it will be back to 1, 0, but now we are 2 pi higher than where we started off. Okay? So how we sketch this, in this case we don't need computer algebra system or Maple to sketch it. We start with t equals 0. Well, when t equals 0, we are at the point 1 0 0. So this is 1 0 0 right there. Okay? With t equals pi, well, the other point right here, but we're never going to be on it because we're going to climb up. But this point right here, just for reference, will be 0 1 0. But notice that will be actually 0 1 and pi over 2. So we're going to be higher. We're going to be right there. And then we're going to go back, and we have another point in the back of the x-axis, and then we'll have another occasion in the back of the y-axis right there, but we keep going up. So the way we trace it, we're gonna end up having a cylinder like so. The base is this circle, right? And we go up. Actually, this should be supposed to be dashed because we don't see this part. And then what happened is we start right here, and then we climb up right here. We go around, keep going up, and then we climb higher to the next position, and then we keep going up. And you can see that what you end up having is a spiral. If I drew it a little bit taller, you could see how this works. So, and the shape is a helix. So what we end up having let me see if I can draw it, is this spiral like so. Okay. So this is the space curve, and what happened is you can see that we move in this counterclockwise direction upward in a corkscrew motion. So this is the helix.